atomic structure. In atomic structure, we need to know what they call the history of development. The history of development about atom can be dated back to the period of ancient Greek philosophers. And the first atomic theory, or let us say the idea about atom, was put forward by John Dalton in 1808. John Dalton, 1808. There are 5 John Dalton atomic theories. 5. And out of these 5, only one is correct. The 5 John Dalton atomic theories are: 1. All elements are made up of small indivisible particles called atom. 2. Atom can neither be created nor destroyed. 3. All atoms of the same element are alike in every aspect and differ from atoms of other elements. 4. When atoms combine, they do so in simple ratio. 5. A chemical reaction is as a result of combination or separation of atoms. Out of all these 5 Dalton atomic theory, only one is correct. So, out of all these 5, the only one that is correct is that a chemical reaction is as a result of combination and separation of atoms. By the time we conclude with this class, you are going to know which one is wrong and which one is correct. Although I've informed you that a chemical reaction is as a result of combination and separation of atoms is the only one that is correct. The John Dalton atomic theory in 1808, the crux, the most important of John Dalton atomic theory is that atom is an indivisible particle. By the time we continue with this class, you are going to see if it is true atom is indivisible or not. But in 1808, John Dalton put forward the idea about atom. And the cross about John Dalton atomic theory is that what? Atoms are indivisible. However, in 1813 to 1814, in 1813 to 1814, a scientist called John Jacob Berzelius gave the symbol of element within a year. And when he gave the symbol of element, he proposed that no 2 elements of different atoms can have the same chemical symbol. That is, the symbol of sulfur must differ from the symbol of sodium, even though both of them start with S. That is, the symbol of an element can either obtain from their Greek letters or the Latin letters, or even the name of the scientist. So, the name of sulfur, the chemical symbol of sulfur is S, while the chemical symbol of sulfur is S, while the chemical symbol of sodium cannot be S, which is what? Natrium. So it's from the word natrium, and that's why the chemical symbol of sodium is what? Is Na. So according to John Jacob Berzelius, the symbol of an atom must not be the same, provided they are not the same. In 1833, 2 scientists come up. That is Michael Faraday and Davy. They perform experiments about electrolysis, and they are able to show that every atom are electrical in nature. Every atom are electrical in nature, but they don't know what to say. But they continue by saying that they may possibly consist of subparticles. They know for an atom to conduct electricity, it means atom consists of something, but they are not sure of what it contains. So they say that what? Atoms are electrical in nature, and they may possibly consist of subparticles. However, in the year 1870, a scientist known as William Crookes discovered what we call cathode ray. In the year 1886, a scientist known as Eugene Ujigossi discovered the anode ray. In the year 1895, a scientist known as Wilhelms Roentgen discovered the X-ray. All these contributions have a wonderful performance in the discovery of atoms. However, in the year 1897, 2 years later, J.J. Thomson performed this charge tube experiment. I repeat that. In the year 1897, J.J. Thomson performed this charge tube experiment where he was able to discover electron. During this time, electron is otherwise known as cathode ray. The characteristics of cathode ray is the same thing as the characteristics of electron. J.J. Thomson discovered electron as one of the subparticles of an atom. Talking about of electron or cathode ray, there are 5 characteristics of electron or cathode ray. Number 1, they move on a straight line which is normal to the cathode ray and cast shadow on any opaque object placed along their paths. Number 2, they attract positively charged pole which indicates they are negatively charged. Number 3, they possess kinetic energy. And cause the motion of mechanical paddle wheel placed along their paths. And the next one, number what? Number 4 is that they have a specific charge which is called electron charge to mass ratio, which has the value of 1.76 times 10 raised to power 11 coulomb per kilogram. This is the charge to mass ratio and is otherwise known as specific charge. So one of the important contributions of J.J. Thomson according to atom is that it suggested and it proved to us that the charge to mass ratio has this value. It did not, that is its limitation. The limitation of J.J. Thomson, he did not give us the charge of electron. He did not give us the mass of electron. He only gave us the charge to mass ratio. That is the limitation of J.J. Thomson. However, in the year 1909, the ADF is Andrew R.A. Millikan performed the oil drop experiment. During his oil drop experiment, he was able to discover the charge of electron. And the charge of electron happens to be 1.6 times 10 raised to power minus 90 kilogram. By combination of what R.A. Millikan did and the J.J. Thomson, we can determine the mass of electron. By calculating, if we determine the mass of electron by calculation, we obtain 9 points. Okay, the charge is in coulomb, thank you. And the mass of electron is 9.1 times 10 raised to power minus 31. We got 31. Am I right or right?
Yes.
31 kilogram. So by combining these two, that is why we obtain the mass of electron. The advantages of R.A. Millikan experiment over J.J. Thomson experiment is that the R.A. Millikan gave the separate value for the charge of electron. However, the J.J. Thomson is unable to give the separate value for the charge of electron. He only gave us the charge to mass ratio. Later, in the 1911, another scientist known as Ernest Rutherford performed the experiment. Listen, Ernest Rutherford performed the experiment known as alpha scattering experiment or gold foil experiment. Gold foil experiment or alpha scattering experiment. Listen, during his experiment, he makes use of radium, place it inside a lead block, which he was able to bombard alpha particle with a gold tiny, is a question in OAU. He bombard a gold tiny with alpha particle, and he prevent that radium with a lead block. It's a question in OAU in which you need to be very careful for. So during his experiment of a gold foil experiment, he was able to prove, keep quiet, he was able to prove that every atom consists of a positively charged center known as nucleus. So we can say Ernest Rutherford discovered the nucleus. J.J. Thomson discovered what? Electron. By continuation, in the year 1913, 4 scientists came up and have this fine discovery. 4 scientists. The first scientist, it was Henry Moseley. Henry Moseley discovered that the number of protons present inside the nucleus is the fundamental characteristics of that atom. That is, the behavior of an atom depends on the number of proton present inside the nucleus. If you are not the one that discovered the proton, you only the one that discovered what we call atomic number. Atomic number is the number of protons present inside the nucleus of an atom. In the same year, 1913, another scientist known as Frederick Soddy discovered what we refer to as isotopes, or you call isotopy. Isotopy is a phenomenon. Isotopes is an element that have the same atomic number but different mass number. Also in that same year, a scientist known as Francis Walter Aston discovered what we call isobar. So, as we have isotopes, we also have what we call isobar. Isobar, they are atoms that have the same mass number. Isotopes have the same atomic number. Are you with me? In fact, it was Frederick Soddy that discovered isotopes, also discovered what we call isotope. Isotopes have the same atomic number. Isotopes have the same neutron number. Isobar have the same mass number. The mass number of an atom, it can be discovered or can be detected by using an instrument known as mass spectrometer. Mass spectrometer. The name of that chemistry field is called mass spectrometry. The instrument used to determine, that is why question 2008 question number 1. The mass of an atom can be used to determine, we can determine the mass of an atom by using an instrument known as what? Mass spectrometer. So it was Aston that discovered mass spectrometer and also discovered isotope. The same year, 1913, another scientist, I told you there are 4, the name of that scientist is called Niels Bohr, discovered that electron revolve around the shell in a planetary manner. The movement of an electron is what is in a planetary manner. However, after that 1913, in the year 1917, Ernest Rutherford again continued his research and he was able to discover proton. In a nutshell, we can say that proton and nucleus was discovered by Ernest Rutherford. Electron was discovered by what? J.J. Thomson. Was discovered by J.J. Thomson. The instrument to determine the mass of an atom was discovered by what? Francis Walter Aston. Francis Walter Aston. All right. Apart from that, in the year 1924, a scientist known as Louis de Broglie, we call it de Broglie, discovered that the electron of an atom, they behave in a two-way. They behave as an electron, they behave as a particle, and they behave as what? As wave. De Broglie said that. During that, as a particle, electron, when it's behaving as a particle, he said that the energy is equal to mc squared. But when it's behaving as a wave, the energy is equal to what? hv. This v is frequency. We can say h is what? Is c over wavelength. By equating this, we can say that mc squared is equal to hc over wavelength. This cuts one of these. We can say wavelength is equal to h over mc. Am I right or right?
Yes.
This E, wavelength E, is called the wavelength, the Broglie wavelength. If they ask you to calculate the Broglie wavelength, the Broglie wavelength is equal to the Planck constant over the mass of electron times the what? Than the velocity, speed of light. So don't forget, the mass of electron has been calculated by what? Ra milligram to be 9.1 times 10 per minus 31 kilogram. Are you with me? After that, in the year 1926, another scientist known as Erwin Schrödinger gave the wave equation of electron. In the year 1927, a scientist known as Heisenberg give what we call uncertainty principle, which states that it is impossible to determine the momentum and position of electron simultaneously and accurately. It's impossible to determine the position and the momentum of electron simultaneously and accurately. And finally, in the year 1932, a scientist known as James Chadwick discover what we call the neutron. A neutron is neutral. It has no charge. Nucleus is positively charged. Electron is negatively charged. And proton is what? Positively charged. These are the basic history of development of what we call atom. As underlevel students, either in OAU, UI, FUTA, Akoba, Adeyemi Federal University of Education, these are the history of these are the history of atom that you need to know. However, as a secondary school student, out of these 18, you just need to know 7. As a secondary school student, you have to know about John Darting, J.J. Thomson, R.A. Millikan, Ernest Rutherford, Henry Moseley, Nebo, and James Chadwick. But for 100 level high institution, all these scientists must be owing in your brain. Thank you so much. My name is William.